One really interesting way to track malicious user activity is to set up a honeypot. A honeypot you can think of as being a decoy or a fake system that is intentionally made to look vulnerable so that we can have malicious activity and track it. So the idea is we want to be very careful with this. You don't want to deploy a honeypot server that itself is made to look vulnerable and have that on a production network with other real servers that are important. That makes no sense. Instead, you want some kind of a sandbox environment, such as running it as a virtual machine that does not have a connection at the network level to production networks. So it's made to look intentionally vulnerable. Now, what we can do then is we can gather some statistics and telemetry about how users are connecting, potentially they're malicious actors, what they're trying to do, maybe brute force password attempts, and if they actually do compromise it, we can even see what they do once they're in, such as installing an advanced persistent threat like a backdoor so they can keep getting in. Or maybe they're trying to use lateral movement to get elsewhere on that same network to other hosts. The idea is we want to be able to learn how are they getting in and how are they getting data, for example, that they shouldn't be getting access to. What a great way to do it. Set a trap. Now, when you do this, you should consider centralized log forwarding as we've discussed previously. Because if an attacker compromises that host, one thing they'll do is wipe the logs. So make sure you have a copy of honeypot logs stored in another location. Now, besides a honeypot, we can also work with a honey file. This is an individual file that is designed to look juicy and sweet to an attacker. Maybe it's called payroll.db, but really it's filled with fake information. And what we could do is enable some trigger alarms on that file, auditing, including file integrity monitoring. Basically, I want to know when someone touches that file and what they do to it, and what they did. Did they read? Did they write? Did they try to delete the file? What was the user account that was used to do that? All of this stuff we need to have logged. And again, ideally that's stored elsewhere so that the device on which that honey file exists doesn't have its logs wiped. So the other thing to think about here too is that we can also have a collection of honeypots on a network, more than one honeypot, at which point we have what's called a honey net. Now, individual honeypots can be made to look like any version of a Windows server or a Linux server, a Unix host. It could look like an Apple iOS smartphone. It could look like an industrial control piece of equipment. So maybe I want to make this look like a Siemens S7 PLC that controls valves in a water treatment plant. We could totally make that look like it really is that and track activity against that PLC emulator, we'll call it. So there are many solutions out there that allow you to set up this type of honeypot environment. So let's take a look at a simple, easy way that you could set up a honeypot for the purposes of tracking malicious user activity. Okay, here in the Microsoft Azure cloud, I have a virtual machine called VM2, and we are currently viewing its properties. I've selected the overview blade on the left so that over on the right we could see the public IP address. Now we know that unless we absolutely need to, we should not make hosts publicly visible to the internet because they will be attacked in a matter of minutes, if not seconds. However, in this case, I do want it publicly visible. I want it to look like a Windows server with RDP, Remote Desktop Protocol, enabled. And so this is a great way to do it. Assign it a public IP address as we've done here. Now, let's take a look at what an attacker might do and how they might discover that this is out there on the network. So here in Kali Linux, an attacker might issue the nmap command with -P lowercase n, because we want to make sure if a firewall is active, we can still see what ports are open, -P for the port of 3389, and then I need to paste in the public IP address of that host. So we can get that by flipping back to Microsoft Azure and copying that public IP. So let's go back into our Linux session and just paste that in and hit enter. So what it discovered very quickly is that indeed port 3389 is open. It's an RDP server. Now from the attacker's perspective, that looks like a legitimate server. They don't know that we just set it up to track their activity. But let's flip back into the server and see what would happen if they started trying to log in with different passwords or maybe issue an attack that does that for them automatically. So here in that RDP server, I can go into the Start menu, go into the Event Viewer, and maybe what I want to track on this honeypot is logon activity. Who's trying to hack into this at the RDP level? So I could go to the security log by clicking security over on the left, and what I would be looking for here are audit failures. Now, if I select an audit failure log event, what I could then do is scroll down. It looks like the administrator account was tried, but it ended up with an unknown username or a bad password. And as I scroll down, I can even get information about the workstation and the IP address from which that attempt was made. So as we can see then, with a honeypot, we can start to track malicious user activity, and here we're viewing the logs directly on the host, but remember, ideally you will have those logs forwarded elsewhere.